Frames are a fantastic way to make data move around. The problem is how do frames know how to get to the right computer? So if you take a look at a network, what we have here is a hub. Now on this hub, if I'm sending data, it's coming in from the white cable. When it gets inside the hub is what we call a repeater. It takes the signal that comes in from one of the ports and then it recreates multiple copies of that and sends it out on all of the other connected cables. So it literally takes one signal and repeats it out to as many connections as you have. Now that creates a big problem. The challenge we have here is I've got a network, all right? So this is going to be 4 computers that are connected to a single hub. The challenge that we have is that, let's say that this purple computer wants to talk to the green computer. What's going to be taking place is that when this purple computer sends out a frame, it gets sent into the hub, and the hub, remember, repeats it out to all of the connections. So everybody gets an example of that frame. Now that frame isn't for everybody, it's just for the green computer. So we need some way to address each of the frames so that even though everybody gets it, only the green computer is actually going to read the frame and use it. These other 2 guys, when that frame comes in, they're going to see that it's not for them and then they'll just wipe it out or consume it so it never goes past the network card. So in order to do that, I want to make an analogy of a network card as a tray. So this, for me, I'm having a little fun here, is a network card. This ugly old vacuum tube from my shop vac is the RJ45, the wired connection into it. So when a frame comes in, it literally plops down and the network card looks at it. Now the problem is there's nothing within that network card that identifies it and says it's for this network card, for this particular machine. And that's where something called a MAC address comes into play. In order to appreciate a MAC address, we're going to have to take a look at a computer. So what I'm going to do is fire up my Windows computer and let's take a direct, close, personal look at a MAC address. All right, now here I am in good old Windows 8. I'm at a command prompt. By the way, what I'm doing here, even though I'm using Windows 8, will work in Windows 7, Windows Vista, Windows XP. In fact, it would probably work in just about every version of Windows there are. So let's go ahead and run a magical command you need to know for the Network Plus. It's called ipconfig. Now, when you type ipconfig by itself, it gives you all kinds of interesting IP information. But in order to see the MAC address, we have to type ipconfig/all. Make sure you know this for the test. So as we run this, you'll notice I have lots and lots of network cards in this computer. That's just the way things go these days. So what I'm looking for is the actual network card that's working for a living. And right now I'm hooked up wirelessly. So here it says wireless LAN adapter Wi-Fi. Now as we go down through here a little bit, what I want you to find is right here. Do you see this? That is your physical address. Now, this isn't hexadecimal, so each one of these characters represents 4 binary characters. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hexadecimal characters. So 12 times 4 is 48 bits. So MAC addresses traditionally are always going to be 48 bits. Now, what I want to do is have you take a look at this. And as you look at this, you'll notice that it's broken up into groups of 2. All right? The first 3 groups of 2 are actually issued to the manufacturer. So Broadcom, who's the maker of this particular wireless NIC, they own the 70-F1-A1. And that's what we call the OEM part of the MAC address. The second part is the unique identifier. Once Broadcom is issued the first half of the MAC addresses, it puts a different set of numbers on every individual network card it owns. So the thing we need to remember is that every network card in existence has a unique MAC address. It has to have that because we never know on our network here whose network cards are going to be plugged in. And it's the MAC addresses that we apply to the frame to make sure it gets delivered to the right place. So each one of these computers has a unique MAC address. So what we'll do, let's take a look at our frame again, is we're going to add to the frame MAC addresses. Now, I've got two blocks here, and that's because we have the MAC address where it's going to and the MAC address of where it's coming from. So whenever your network card sends out a chunk of data, it's very important to the network card that not only does it know where to send it to, but it also will put its own MAC address in there so the receiving computer can send it back. Now, the other thing that will come into play here is a CRC, or a cyclic redundancy check. This is just used as a way to verify that the data is good. If it's bad data, then it knows to resend it. So what we'll do, let me go ahead and get it pointing in the right direction, is once this is all created, it gets sent out. I'm not going to push it through too far because I'll never get it back. But push, off it goes off to the network. Now, the cool part to all this is that as it leaves this computer and comes into the hub, remember that the hub creates as many copies as necessary to represent all the different computers it's connected to. So it makes, in this case, 1, 2, 3 new copies, and it sends them down the line to all the individual computers, and as these frames come into the computer, boop, it drops down on the tray. And the cool part is that every network card knows what its MAC address is. So the card looks at this. If it's a MAC address for him, then it's going to strip away all this extra information and send it up into the software of the system. However, if it's a MAC address that's not for him, he'll look at it, see it's not his MAC address, and he just makes it disappear and doesn't do anything with it. And that is how MAC addresses work.